So this is the predicted paper that I have put together for paper 2 on Wednesday, higher tier Edexcel calculator paper. I've looked at the last 4 years and analysed topics that have come up quite often, and there's a few that haven't been on there for a while that might crop up. It is a best guess paper. I can't guarantee that any of the topics will come up, but hopefully there will be something in there that will be useful. So yes, I'm going to go through the paper doing the work solutions now, and please let me know afterwards if you've got any questions. So let's start with question 1, and it's asked for the highest common factor of 60 and 114. This is really common and has been on every single year on one of the papers, and it didn't come up on the first paper, so it's likely to be on this paper or the paper 3. So you've been asked to find the highest common factor of 60 and 114. The quickest way to do this is actually on your calculator. Unfortunately, I don't have an emulator, otherwise I would be able to show you. So I'm going to do it manually, and then I will talk you through how you do it on a calculator. So if you don't have a calculator, the first thing you will need to do is to find the product of prime factors, or write 60 and 114 as products of prime factors first. So 60, you start with the first prime number, which is 2, and that is 60 is divisible by 2, and I've put it in a bubble to show that it's a prime number. What do I multiply 2 by to get 60? That's 30. And then can I use 2 again? Yes, I can. So I use 2 again. It looks like a factor tree. And then that's 2 times 15. Can't use 2 because 15 isn't divisible by 2. So I use 3, which is the next prime number. And that's 3 times 5, and that's a prime number, so we stop there. So 60, if you were to write it as a product of its primes, would be 2 multiplied by 2 multiplied by 3 multiplied by 5. I don't need to write that out for this question because I haven't been asked to write it as a product of its prime factors. So now I'm going to do 114 in the same way. We've got 2, and that's 2 lots of 57. Give me 114. 57 isn't divisible by 2, so I now move to the next prime number, which is 3. And that's going to be 3 lots of 19, which is a prime number, so I stop there. So again, if you were asked to write 114 as a product of its prime factors, it would be 2 multiplied by 2 multiplied by 19. So now what you want to do is draw yourself a Venn diagram. And you're going to put anything that is in both of these threes in the middle. So I've got a pair of 2. So each pair that you've got, you write one number in the middle. And then I've got a pair of 3s. So I'll cross those out and put 1 3 in the middle. Nothing else is common to both. So my remaining numbers, so I've got here, I've got a 2 and a 5. So I'm going to put that in the left-hand side. And over here I've got a 19. So that goes on the right-hand side. So that's my Venn diagram. So if you want your highest common factor, which is what this question is asking me for, all I need to do is times together the numbers in the middle of the Venn diagram. So 2 multiplied by 3 will give me my highest common factor, which is 6. And that's how you do it. If you were asked for your lowest common multiple, which it could be either or, you multiply all the numbers together in the diagram. So if we were asked for the lowest common multiple, I'll just do that quickly over here. I would do 2 times 5 times 2 times 3 times 19. That's all the numbers in the diagram. But I've only been asked my highest common factor, so my answer is just 6. Now, if you're doing this on a calculator, because it's a calculator paper, so you should use it, and people often don't use their calculator and make really silly mistakes. I see it all the time. It's really frustrating when you're marking and a student has done a multiplication, simple multiplication, and not got it right because they haven't used their calculator. So anyway, what you need to do, I'm going to have to try and draw this out for you. So if you've got a calculator, you want the Casio ClassWiz calculator. That's because not all calculators will do this, but the Casio ClassWiz will do this. So you want to look for the button. It looks a bit like a book. Let's see if I can draw it here. and it's called Catalogue. I mean, that's a terrible drawing, but anyway, you want to look for it. It's on the right hand side at the near the top, and it looks like a little book, and it's called Catalogue. Then what you need to do is you need to go to mathematical, I think it's called mathematical calculation or numerical calculation. So I don't have a calculator with me at the moment, so I can't have a look for you, so I'm doing this from memory. It's called numerical calculations or something similar. And then you'll get two options that you'll see here. You'll see GDC and LCM. Well, GDC is greatest common denominator, which is the same as highest common factor, and LCM is lowest common multiple. So you can use this bit to do both. Now all you need to do is literally click on GDC. So you're going to click here, click on GDC, and it will say GDC, and it will open up a bracket. So you put the first number in, which we've got here is 60. You then need to put a comma, which can be found by using shift. It's above one of the other buttons. So you press comma, shift comma, and then you type the other number in, which is 114, and close the bracket. It's literally that simple. You press enter and it will tell you the answer is 6. So that's how you do it on a calculator. Okay, question number 2. So I have been asked to factorise. So I have shown this method previously. You don't have to use bubbles, but it's a nice way to set out your factors. If you've been asked to factorise, you are taking out the common factors. So I can't seem to draw very straight on here. It says factorise, so you are taking out the common factors. So first of all, I need to look at 12 and 8 and see what is the highest common factor, the highest number that goes into both 12 and 8. Well, that is 4. So I put 4 in both of my bubbles. And then, what do I multiply 4 by to get 12? Well, that is 3. And in the right-hand bubble, what do I multiply 4 by to get 8? And that is 2. So there I've got my 12 and my 8 there. Then I've got m on 12m, so I need an m in my left bubble, and I've got m squared here, which is m multiplied by m. So I have 2 m's in the right hand bubble and a plus in the middle. So now what I do is I look for my common factors to both bubbles. So I'm taking out the highest common factor, which is 4, and I also have an m in each bubble, so I can put an m on the outside as well. I open up my brackets and then I pop inside what I've got left. So I've got a 3, a plus in the middle, positive sign, and I've got 2m here. And that's it. That's factorised. You can obviously, lots of people can do that in their head without using the bubbles, but some people like to have something visual, so I find that helps. You can always check your answer by multiplying your brackets back out again. So 4m times 3 gives me 12m, so that's correct. 4m multiplied by 2m gives me 8m squared, positive 8m squared, so that is correct. So it's just a quick way to check that your answer is correct once you have factorised. So part B has asked me to solve this equation, and you see here it's worth 2 marks. It's quite common, and normally, not always, but normally 9 times out of 10 your first mark is just for expanding the bracket. So even if you don't know how to solve equations, everybody can get the mark for expanding the bracket if you know how to do that. So you do 3 multiplied by n, which is 3n, and then 3 multiplied by 5, which is negative 5, which is negative 15, and that would usually give me a mark without having to do anything else. So now I'm going to have to solve it. So I've got 3 lots of a number, take 15 is equal to 27, so I'm going to work backwards. The opposite of taking away 15 is to add 15. I show that on both sides of my equation. 27 add 15 is going to be 3742. See, I'm doing this without a calculator. I might be making silly mistakes here. Don't do the same as me. Even if it's as simple as 27 add 15, use your calculator. I know it sounds silly, but in exams you are stressed and you make mistakes under pressure. So 42 there. This has cancelled each other out here because negative 15 add 15 is 0. So I've just got 3n left on the left hand side. So 3 lots of a number is 42. The opposite of timesing by 3 is to divide by 3. And I always write that as a fraction because if you get a number that doesn't divide exactly, you can leave your answer as a fraction and still get 4 marks. But in this instance, 42 does divide by 3 and you get 14. N is equal to 14. And that is it for 2 marks. So quite a lot for the second mark there. First mark should be nice and easy for most of you. Okay, let's have a look at the next question. So this is question 3. You have been asked to complete a table of values. It's very annoying that I do not have my emulator set up yet and I don't have a calculator because, again, you can do this very easily on your calculator. So I'm going to do the same as before. I'm going to show you how to do it manually and then I will explain how you can do it on your calculator if you've got the Casio calculator. So I've got to complete the table of values for y equals x squared add x, and I'm going to write that out because it's a bit blurry. Y squared, what am I doing here? Sorry. Let's try and type that again. My pen is a little bit thick, so I'm just going to change the thickness here. Okay. Y equals x squared add x take 6. So I've got to use this to fill the values in the table. So that's telling me in order to get y, I have to square x, add x, and then take 6. So that's exactly what I'm going to do. You're just substituting in values. So I always recommend starting with the positive values, less likely to make mistakes there. So if x is 3, I'm going to just write 3 squared. And again, if you put it in brackets, you can put that in straight into your calculator. Add 3, take 6. So every time you replace a letter with a number, you put it in a bracket. That stops you making mistakes with the signs on your calculator. So I haven't got my calculator, so I'm going to work this out manually. 9 add 3 take 6. So that's going to be 12 take away 6 is 6. So that's my first value. And then obviously you would do the same with the rest. So let's go for 1. So I've got now x is 1. So I'm going to do 1 squared add 1. Should be much quicker for you because you can type this into your calculator. 1 add 1 take 6. That's 2 take away 6, which is negative 4. So that's my next value here. Then I'm going to do negative 1. Now this is where people often make mistakes with the negatives, especially if you don't use the brackets and especially if you don't use your calculator. And you don't want to lose early marks on a higher paper at this stage. So negative 1 squared add negative 1 take 6. Now if you didn't put this negative 1 in a bracket and put it in your calculator as negative 1 squared, it would tell you that negative 1 squared is negative 1, which is incorrect because it would only square the 1 and not include the negative. This is negative 1 multiplied by negative 1, which is positive 1. Add negative 1, take 6. When you add a negative, you're decreasing, so you're taking away. So 1 take 1 is 0, take away 6 is negative 6. Again, much simpler if you've got a calculator and you're able to input these values in with the brackets. Don't forget the brackets. So I can already see here from this that this is starting to mirror. And if you know about quadratic graphs are always a U shape. That's what makes them quadratic. And that's why they start to mirror, because you have the y values start to mirror either side of the graph as it goes up. So I can already fill in the rest of the table without doing anything else, because these are both negative 6, so these would both have to be negative 4, and then therefore these must both be 0. So I don't actually have to work out any more negatives and don't risk making any more mistakes. But you could always do that just to check for yourself. So if you are on a calculator doing this, you can either do as I have done and input these calculations with the brackets, or you can go to your menu and you want to select table. And it will bring up a table that looks like this. So you'll have x and you'll have f of x. Well, f of x is the same as having y there. Okay, so all you're going to do is you're going to input your x values in here, and it will tell you your y values here. It's very straightforward. But before you do anything else, what you need to do before you input any values, you need to click. There's a button on your calculator on the Casio that looks like this, FX. And you click on that, and you'll get a list of 4 options. I believe it's you get FX, GX, and then define FX and define GX. You're defining f of x. All that means is you're telling the calculator what the equation is, so it knows how to work out the y values. You're defining the equation, basically. So you click on there, and then you literally type this equation in here. So I've written over it now, so it's very difficult to see, but you're going to type in this equation here. But you don't need to type all of it, because you're defining f of x, which is y, so you don't need the y. You're just typing in this. So type in, and there's again on the Casio ClassWiz, there's a button with a little x on it. So you use that x on your calculator to type x in. So you type in x, and you press the squared button, plus x takes 6. You type that all in. Now, once you've defined that, you go back to, it'll take you back to your table, and you can literally input your values. Now, once you've inputted the first value, always start with the lowest here. Once you've inputted the first value, which is -3, you can just press your equals button. It might be equals or exe, depending on which calculator you've got. You press these, and it will just automatically know that it's going up in ones, and it will input the rest of the numbers for you. And as you input these, you will see the y values start to appear here automatically. It calculates those all for you, so nice and quick. All definitely worth using if you have a Casio. I've obviously missed a number here. What have I done there? Is it -3, -2, -1, 0, 1, 2, 3, 1, 2, 3, 4. Oh, it's because I haven't spaced those out right. But hopefully you see the idea anyway. So that's how you can do it on your calculator. Shame I haven't got one to show you on at the moment. I will get that emulator up and running. So that gives me 2 marks for my table. What I need to do now is I need to plot these. I'm going to do that in a different colour. I'm going to do that in green. And these are coordinate pairs. So I'm going to plot -3, 0, which goes here. -2, -4, which is here. That was my next coordinate here. Then -1, -6. Now I'm going to have to go down a bit because we can't see the rest of it. There we are. -1, -6 is there. And then my next one here is 0, -6. 1, -4. I apologise for the screen. I will get better at this as I go along. 2, 0 is next, and then I've got 3, 6 is next. Now, if I left it like this, I would only score 1 out of 2 marks. You must join up your graph. Oh, and that's terrible there. You must join it up, and you must, with a quadratic, they won't mark it correct if you do it with straight lines. You do it freehand. It must be a curve, and it must have a curved bottom. I think I've told you this before. It's got to be a peachy bum. It's got to be a peachy bum, so you don't want a flat bottom at the bottom there. I've gone over that and I've made that look worse, haven't I? But this is why you should, if you're in your exam, you should be making sure you do all your drawings in pencil, because if you make a mistake like me and your line goes a bit wonky or skewy, then you can rub it out and make sure it's done properly. But that is how you do those. Very likely to come up. Quadratic graphs is they did have a linear graph question on paper 1. However, they quite often put another graph question on another paper. Could be quadratic, could be exponential, could be cubic. But either way, as long as you know how to use that table function, you've only then got to plot them and join them up. It should be pretty straightforward, but very likely to be there. Use your graph now to find estimates of the solutions to the equation. So now what we need to look at here, I'm going to write the original equation actually out again under here. I'm going to write the y here where it would be here because it's been replaced. So my original equation was this. Again, I've not drawn that very well, so let's try that again. So we've got x squared add x minus 6 equals negative 2. The original equation was x squared add x minus 6 equals y. So what that is telling me is they want you to find the solution because they've replaced y with negative 2, when y equals negative 2. They want you to find that solution. So on my graph, where does y equal negative 2? That's here. Remember, this is x equals negative 2. Y, so that's not correct. Y equals negative 2 is here. So I always draw a line, obviously do that with a ruler and a pencil across like that. So you're finding the solutions of where this line crosses the graph, and you want to know the values of x at that point. So you just go up here from your line. Now, again, I've not drawn them very well. It's very difficult to use a ruler on here. I'd be here all day. So, but you should be using a ruler and a pencil. So on here, I'm going to have negative x equals negative 2.5, and, or you can put this one here, which is 1.4. They give you a little bit of margin of error or leeway because everybody's graphs will be slightly different. So you can be normally 0.1 out either side, but it will be around those values there. And that is it. You get marked for each of those being correct for 2 marks there. 2 marks for the graph and 2 marks for the table. So 6 marks, a lot of marks. That's nearly half a grade on a paper, just in one question. Okay, ratio. Some of you say the dreaded ratio. Now just remember, ratio is just telling you how many of each thing you have. Okay, if you think of it in that simple terms, you can tackle any ratio question. So I've got, in a village, the number of houses and the number of flats are in the ratio of 7 to 4. So that's telling me houses and flats. I've got 7 houses and I've got 4 flats. Now, this may have been simplified down, so I probably would have had a lot more houses and flats, but it is literally telling me if I've got 7 houses, I've got 4 flats. And then I've got the number of flats to bungalows is 8 to 5. Okay, it tells me that here. And it's houses, flats, 7, 4, flats, bungalows, 8, 5. So I always write it out separately. Again, you would obviously put yours in the working out. I've done mine to the side here because I've got a bit more room. So the first thing that I noticed, well, actually, let's read the rest of the question first. There are 50 bungalows in the village. How many houses are there? Well, if I look at this, there's not 50 bungalows, I've only got 5. So we know the ratio has definitely been simplified down. But before I can do anything else, you have got to combine these ratios because they're separate at the moment. So this is houses and flats, this is flats and bungalows, and I can't just put them together because if you look at the flats, they're different. So you can't just say it's 7, 4, 5, that wouldn't work. So if there are 4 flats, there are 7 houses, but here I've got 8 flats. So let's make this flats equal this one. So I'm going to make this equal 8. And in order to make that equal 8, the number of flats, I have multiplied the number of flats by 2. 4 times 2 is 8. So I do the same to the number of houses. And 7 times 2 is 14. So I've got 14. If there are 8 flats, I've got 14 houses. And I know I have 5 bungalows. I can put them together with 3. So this is houses, flats and bungalows. You had to make the common property type the same in this question first. Now, as I said, we also know we're looking there. It's telling me here there are 50 bungalows. So the bungalows has been simplified down. So what would I do to 5 to make it 50? And whatever I do to this part of my ratio, I have to do the same to the others. Well, I would multiply it by 10. So I have to multiply the others by 10 as well. And that's all of them. Well, I don't actually need to do it to all of them. I'm only asked how many houses there are. So I've only got to multiply the houses by 10, which is 140. So therefore, my final answer is 140. It might ask you something different, so you might need to do it to all 3. But that is it for 3 marks. So just remember, ratio is just telling you how many of something there is. And it might have been made smaller by dividing, or you might have to make it bigger again by multiplying, or you might have to simplify it down. But it just tells you how many of each thing you have. We have question 5, and this is telling me a circular field. We can see that because there is a diagram there. Has a diameter of 32 meters. A farmer wants to build a fence around, now that's the key word here, the edge of the field. Each metre of fence will cost $15.95. Work out the total cost. So the first thing in this question to look at is it's giving you the diameter. Now the diameter, and people sometimes get this wrong, is all the way across. The radius is halfway across. So I'm just going to pop that on my diagram. So that's 32 metres. A farmer wants to build a fence around. Now this is the key information here that often people miss and get wrong. We're going around here, around the diagram. That's not drawn very well, but you get the idea. So if we're going around, that is perimeter. If it's asked you to cover something, then that's going to be area, but this is asking me around. Now, when we have the perimeter of a circle, you should know that the perimeter of a circle is called the circumference. Now, there is a formula for this on your formula sheet. Okay, so if you make sure you use that and have a look at that. The circumference is just pi d, pi times the diameter, or you might see it written as 2 pi r, which is the same thing because 2 lots of the radius is the same as the diameter. So these two formulas are essentially the same thing. So all I have to do here to get the distance around the edge, because I need the distance because it tells me the cost in meters of the fence. So I'm just going to do pi times my diameter, which is 32, and you'll pop that into your calculator and that will give you the total distance around the edge. So I'm just going to quickly pop that into my calculator. So I'm going to do pi times by 32, which gives me 100.53, or you might want to leave it at this stage as 32 pi. Because then you're not rounding too early. So actually I would probably leave my answer now just as 32 pi and don't convert it to a decimal. So each metre of fence will cost £15.95. So that's every metre. So this is how many metres I've got. So every metre is going to cost me £32.95. So I'm going to do 32 pi, my total distance, times by 15.95. So this would get you your first mark here, and then this calculation here would get you your second mark. Now because my answer is in pounds, I'm going to round that to 2 decimal places because money typically works in pounds and pence. So I'm going to do 32 pi times by 15.95. Or what you can do is use your previous answer button, and that puts in your, so if you've done pi times 32 and you've cleared it from your calculator, you can then use your answer button on your calculator. That puts your previous answer in and times by 15.95, because that avoids rounding too early as well. Don't round until you get to the end of the question. So that gives me an answer of 1,603 let's write a few here, 468,890 and so on. Now because it's in pounds, I'm going to round that to 2 decimal places. So I want to round that to here. So that is going to round to 1,603,603 pounds. And because of this 8, it rounds the 6 up to a 7. So it'd be 47 pence. And that's what's going to get me my first mark, with it correctly rounded and not having rounded too early. So that's worth 3 marks there. Okay, question 6. I'm just going to zoom out a little bit here so you can see the question. So transformations are on the paper every year, and there hasn't been one on paper 1, so that means there's definitely going to be one of the 4 transformations on paper 2 or 3. I went through these on my paper 1 walkthrough, so if you need a refresher on that, you can have a look at the question from my predicted paper 1, where I had a transformation question on there. So if you, there are 4 different types of transformations, and you've been asked to describe this. This is important, the single transformation that maps A onto B. If you start muddling them up and mentioning more than one transformation, you're not going to get any marks at all. So it's going to be one of 4. It's going to be either a translation, a rotation, an enlargement, or a reflection. And you only mention things that are relevant to the transformation that you're discussing. If you're not sure, then only write what you know. So a translation means it's been moved, but it hasn't changed size or shape. A rotation means it's been turned. Enlargement means it's been made bigger or smaller, and a reflection is a mirror image. So actually, I've happened to write the correct one at the top here. We can see it's just been moved from A to B. It's been moved. It hasn't changed shape or size. It's not been turned around, so it can't be a rotation. It's not been made any bigger or smaller, so it can't be an enlargement. And it's not a mirror image, so it can't be a reflection. So I'm just going to write translation. That's my first mark. It's worth 2. Okay, now if I don't know what to do to get the next mark, don't write anything, because you'll get a mark for noticing it's a translation. Because if you accidentally mention one of the criteria from the other transformations, you're going to lose this first mark. The second mark for a translation is not describing it in words, for having the vector, which describes the movement that's taken place here. So the top part, the top number of the vector tells you left or right, and if it's moved left, it will have gone in the negative direction, and if it's gone right, it will have gone in a positive direction. So left, if it's gone left, you put a negative sign. If it's gone right, you put a positive sign. And the bottom number tells you whether it's gone up or down. Up is positive, down is negative. So that's how you write the vector. Do not write a fraction. It's not a fraction. You don't want a line here in the middle. You don't want that. Okay, if you do that, they won't mark it correctly, because that's different. A fraction is not the same as a vector. A vector describes movement. So let me just rub out this line that I put here previously. Let's get rid of that. So I need to see, I would pick a point on here because I need to see how far it's moved. And you're going from, this is important, A to B. So you start at A and you're going to end up at the same point on B here. So I can go 1, 2, 3, 4, 5, right. So that's going to be a positive 5 because right is positive and right is and left are at the top. And then I have gone 1 down. So down is negative. I've gone 1 down. And that's it. So that's what I would put to get my second mark. You don't need to write anything. You just need to write your vector. You can always check that with your other points to check that you've done it correctly. Because again, in exams, you make silly mistakes when you're rushing. So I would just check the other points. 1, 2, let's check here. 1, 2, 3, 4, 5 across, 1 down. Yep. And then 1, 2, 3, 4, 5 across, 1 down. Yeah, so I've checked to make sure that it is correct. So that is my answer for 2 marks. Now have question 7. And this is about, it's got ratio and percentages in it. So let's talk through the question and then I can talk about it to you. So Amy and Poppy were both given a pay rise. Amy was given a 25% pay rise and Poppy was given a 4% pay rise. The ratio of Amy's salary to Poppy's salary is now 9 to 13. Poppy's pay before the pay rise was 50,000. Work out Amy's pay before the pay rise. So this is involving quite a few things. There's always a lot of ratio on the papers. So it's always good to practice ratio. This is also involving a reverse percentage question because you've got their salary now, but you need their salary before. That's the key word there, that it's a reverse percentage question. Now, if you remember the question we looked at earlier, ratio just tells you how much that they are earning. So reverse percentages has been on the paper for 3 out of the last 4, on either paper 1 or 2. It wasn't on paper 1. So yeah, I think it's very likely it's going to be on paper 2 or 3. So let's break this down then. So what I would start with is the ratio that you've got here. So you've got Amy to Poppy, and you've got 9. That's essentially saying if Amy earns £9, Poppy earns £13. Okay, so that's what it's saying that they're earning now. Now they're gonna have more than that. It's gonna have been simplified down, but that is essentially what it's telling you. So we now know that Poppy's pay before the pay rise was 50,000. So Poppy's pay before the pay rise was 50,000, and now she's got £13. Well, it's not going to be £13, is it, if she had £50,000 before? So what I would do is I would use this bit of information here. She's got 50,000, I've put 5, 50,000 before the pay rise. We know she had a 4% pay rise. So we can work out how much she's got now. So we can then use this ratio and work out how much they've actually got, because it's going to have to be multiplied up. So 50,000, and I'm getting a 4% rise. So on your calculator, you can times that by, if you times it by 1, it's going to keep it the same. But if you want to increase it by 4%, you times it by 1.04. 0.04 is what 4% is as a decimal. So that will just calculate that all for you in one go. So if you pop that into your calculator, that's going to tell you how much Poppy has now. So 50,000 times by 1.04, she now has 52,000. So 52, that equals 52,000. So I'm going to write this out again. So I've got Amy and Poppy. This is telling me that they have £9 and £13. Well, we now know that Poppy doesn't have £13. Poppy has £52,000. So we can work out what's happened to this ratio here. What has that been? How's that been simplified? So I need to work out what has 13 been multiplied by to get 52,000, because then I can apply the same to the other side of the ratio. So I'm going to do the reverse of multiplication, which is division. So I'm now going to do 52,000. Keep writing 5,200. 52,000 divided by 13 to work out how my ratio has been scaled. So I'm going to write 52,000 divided by 13, and that's 4,000. So my ratio needs to be scaled up by 4,000, because this has been times by 4,000 here. So I've got to times this side by 4,000 as well, because the ratio has to stay in the same proportion. So I'm now going to do 9 times 4,000. So 9 times 4,000, and that is going to be 36,000. So we now know that Amy has 36,000. So I've worked with percentage now, and I've worked with scaling up my ratio. So I now can use this. This now becomes a reverse percentage question. So we know that now Amy has 36,000. And that was after a 25% pay rise. So reverse, I did a question like this on my predicted paper 1, but it didn't come up on paper 1. I like to use, for reverse percentage questions, I like to use a 6-pack. What every man wishes they could have in the summer. So we start with what she's got now, which is £36,000. And we know that's after a 25% pay rise. So that was, we add that on to 100%. 100% plus 25% is so that this is now 125% of what she originally had, because it was a pay rise. If you go down, you subtract the percentage. So the original amount, what she would have had before the pay rise, that would have been my starting amount, which would have been 100%. So we've got to work backwards from 125% to back to 100%. So on a calculator, what I would always do, because it's quite easy to do because you've got a calculator, is just work out what would a 1% be. So if I know what 125% is, to get 1%, you're not dividing by 100 like you would do normally, you're dividing by 125, because this amount she has is worth 125% of its original value, because it's had a 25% increase. So I'm going to divide 36,000 by 125, work out what 1% would be. So 36,000 divided by 125 is 288. So 1% is 288. So therefore, let's just write that in blue so you can see the difference between my operations and my answers. 288. So I now need to get from 1% to 100%. Well, that's easy. I'm going to times by 100 because I now know what 1% is. So I times that by 100 and you will get 28800, which is 28,800. So that is my final answer. That was her pay before the pay rise. So there you have it, 5 marks there. So I would say you've got a mark, first of all, for working with this ratio here. So first of all, you would have got a mark for this, for timesing by 1.04, to work out that Poppy now has 52,000. You'd have then got a mark for working with the ratio and working out that it's been multiplied by 4,000. Another mark for then applying that. You sometimes normally get a mark for recognising that 36,000 is equal to 125%, and then obviously you'd get your 5th mark for having the answer correct. Or the mark could have been here for dividing by 125 or timesing by 100. There are other ways of doing reverse percentages questions. I just think it's quite nice to set it out like that visually. So 5 marks if you've got 28,800 as your answer. Okay, so here we've got question number 8, and this is a mass density volume question. Again, very common. It's been on paper 1 or 2 twice in the last 4 years, but it does also come up on paper 3, so I think it's likely that you'd have a mass density volume question, if not on paper 2, on paper 3. So the diagram shows a triangular prism, or we can see that from the diagram. You've been given the height and the base of the triangle, but we don't know the length of the prism. The prism is made from wood and has a mass of 643.8. The density is 1.85 grams per centimetre cubed. So it's important to look at the units here. It says grams, well that's good because my mass is in grams here, and it says centimetre cubed, well that's good because my measurements are in centimetres. If they are not the same, you would need to convert. So make sure you check your units on every question, because it's a really easy way of losing marks. I've got to calculate the length of the prism. So let's first of all work out, if I need the length, I'm going to need the volume of the prism first. So you need this triangle here. And this is mass density volume. And if you forget, they don't give you this on the formula sheet. If you forget this, then you are a massive div. Hopefully that might help you remember the triangle. So the M goes on the top, because people often get that wrong. Massive div. There we are. Okay, so we are going to work out the volume of the prism. So because I know I can do that because I've been given the mass and the density. So that's my key there. So if I'm doing volume, I'm going to do mass divided by density. And as we know, the units are all correct, so that's fine. So I'm going to do 643.8, which is my mass, divided by my density, which is 1.85. You can use the fraction button on your calculator, or you can use divide. If you're using divide, make sure the 643.8 goes first. Or just stick with your fraction button. So that gives me 348. Now, because it's a volume, 348, I know that's going to be, it tells me here, centimetres cubed, which is fine because my measurements are in centimetres anyway. So that's my first mark for using mass, density, volume. You'd either get 1 or 2 marks there. Now I've got to work out the missing length. So I need my volume formula. Now on the front of the exam paper it has volume of a prism, which this is. And again, in my paper 1 walkthrough, predicted paper 1 walkthrough, I talked about what a prism is. But there's a shape on the front that looks like this. But essentially a prism is the same shape all the way through. So the same as this front face. If I was to cut this anywhere else, it would have that same front face there, so that's what makes it a prism. So the area, the volume of the prism is written on the exam paper. It says area of cross section times length. Now your cross section is just this bit that I've put in red here, so the shape that it's going to be the whole way through. Now if we look here, we can see that it's got a triangular front face. It's basically the front face. So it's going to be the area of this front face. So look, I'd have it at the back there. If I was to put it here, look, my shape here, I would still have that. That would be my cross section there. So yeah, I've got to do the area of the triangle at the front, the area of my front face, and then I've got to times that by the length. So I'm now going to substitute in the information that I know. So this is a triangle on the front here. So to do the area of a triangle is base times height. Don't forget to divide by 2. Often people forget that with a triangle. 8 times 6 divided by 2. That's the area of my cross section times the length. I don't know it, so I'm going to put x, and I already know the answer because I worked that out here, is 348. That would definitely be a mark for substituting into your formula there. So now I can work out the bits of information that I know. Well, 8 times 6 is 48. Divide that by 2 is 24. So that's there. So I would say we're up to 2 marks now. My next mark is for then solving this. The opposite of timesing by 24 is to divide by 24. So x is going to equal 348 divided by 24. So I'm going to do 348 divided by 24. Showing that calculation there will be your next mark for showing you know you need to divide by 24. And then your final answer for 4 marks is 14.5 centimetres. You would get all 4 marks if you had just put your answer, but I would definitely recommend showing you're working out, because lots of opportunities to make mistakes there, and you can get lots of the marks for the working even if the answer is incorrect. So 14.5 is the correct answer for 4 marks. Okay, so let's move on to question 9. So question 9, I can see straight away here I've got angles and lengths and right-angled triangles, and I have been asked, it tells me here, it shows 2 right-angled triangles, calculate the value of x. If you're working with right-angled triangles and you're working with lengths and angles, you're either going to be looking at Pythagoras, which they give you on the exam paper, a squared plus b squared equals c squared, or you're going to be dealing with SOHCAHTOA, and they do give you some information for this on the formula sheet. I like to use the triangles, but they give you sine x equals O over h, cos x equals a over h, and this is the information they give you on the formula sheet, and they give you tan x equals O over a. So they give you that on the formula sheet. Okay, so let's have a look at this question. So if you're going to do Pythagoras, then that's sides only. You're only dealing with sides only, then it'll be Pythagoras. And this only works in right-angled triangles, so that's the clue there that you're going to be using one of these. This one is sides and angles. Sides and angles. So I can see I've got angles here as well, so I'm assuming, without having worked through the question, it's going to be mainly either all SOHCAHTOA or mainly SOHCAHTOA. So I've got to calculate the value of x over here. Now, in this bottom triangle here, the only thing I have is an angle. That isn't enough to work with there. Okay, you need a side and an angle to use SOHCAHTOA. To use Pythagoras, you need two sides to get the third side. So I'm going to have to work out something that tells me in my top triangle first. So let's just look at this triangle at the top. Forget the one at the bottom is there for the moment. And I have got a side and I have got an angle. That tells me I can use SOHCAHTOA. And actually it would help to work out this side, which I'm going to call y, at the bottom here. Because if I know this side, that also gives me a side in the bottom triangle, which I can then use to work out x. So it is just going to be SOHCAHTOA. So with SOHCAHTOA, the first thing you do is you label your sides. You label the one you've been given, which is the 5. And this is the adjacent side because it's next to the angle. Adjacent means next to. It's not the right angle that we're looking at, it's the angle we've been given. So this is next to the angle, so it's the adjacent side. And this y, the one we're trying to find, is opposite the angle. So that's the opposite side. If you don't need to label this one up here because it's not involved in the question and you haven't been given it. So you don't need to label it. Only label two of the sides. The side you've been given and the side you're trying to find. This would be the hypotenuse because it's opposite the right angle. But I don't need to label that one. That's just going to confuse me. Okay, so I have got A and O. So that tells me that I am using tan here. Okay, so I like to write this in a triangle, which you can do if you've got that information there. You can write TOA like this. The tan, it goes up like a triangle, up and then down, TOA. Okay, so I am working out O, which is my side that I've labelled Y. So if I'm going to work out O, that tells me that I am timesing T by A. So I'm doing T, which stands for tan. The angle always goes with tan, sin or cos. So the angle is 50. When it opens up a bracket, that's what it wants. It wants you to put your angle in there. Make sure you close the bracket or you're going to get the wrong answer. Tan 50 times A, which in this example is 5. So I'm going to do tan of 50 multiplied by 5, and that is going to give me side Y there. So tan 50, close the bracket, don't forget to do that, multiplied by 5, and that is going to give me, and I'm going to not round again, don't round too early because you could lose an accuracy mark if you round too early. 5.95876, etc. Now this is where your answer button in your calculator becomes handy because it will put the whole of your previous answer in. Okay, so that is side Y there. So let me just get rid of some of these bits on the diagram so you can see what I'm doing. Doesn't seem to want to erase those. Okay, so I now know that the side that I've been given at the top here is going to be, I'm just going to put 5.96 for now, just for the sake of showing you what to do. That's that side at the top there. So now I'm using this triangle at the bottom only, this triangle here. So I'm only looking at this triangle here. But yes, I'm only looking at this triangle at the bottom here. So I'm going to use the same process again. I'm going to label the sides. So I have been given, I know I've just worked out 5.96, which is this side at the top here. And that is again next to this 38 because I'm now using the triangle at the bottom. So that is, again, I've got the adjacent side in this bottom triangle. So this is a separate triangle to the top one. So it wouldn't be adjacent in the top triangle, but it is adjacent in the bottom one. And x, which is the side I'm trying to find, is, again, it's opposite the angle. So again, I have A and O. I don't label this one because I don't have it and I'm not trying to find it. You only label two sides, the one you have and the one you're trying to find. So I'm now going to do this calculation in blue so you can see the difference. We know A and O is tan, so I'm going to use tan again. Because I am now and I'm finding O again, so it's going to be exactly the same process. So I'm going to do tan, and in my bracket goes 38 because that's my angle, multiplied by the side that I've got. Now this is where on your calculator I would put answer. Use your answer button because it will put this answer, or the full answer, straight in that you've previously put. So you work that out and that will give you side x. So times that by tan of 38 and that gives me 4.65549976 and so on. Now, this question doesn't tell me to round. Sometimes they do that, but more often than not, they will tell you to round. If they don't, I would write a full answer, like I've done here, a long answer, and then choose a suitable way to round it. And I would just round to one decimal place if you're not asked. So 4 point, and that rounds to 4.7, because the 5 rounds the 6 to a 7. And then that would give you all of your mark there. So that was worth 5 marks, a lot of marks there, because you've had to use tan twice, and then you've obviously had to get your answers, because it's quite tricky because you've got two triangles stuck together and that often confuses people. So I would recommend thinking them as two separate triangles and doing the calculation step by step, like I have done here. So I'd imagine you'd get a mark for recognising that you need to use tan. Then you'd get a mark for this calculation here, and for this answer here that would probably be 3 marks, then 4 marks for doing this last calculation here, and then 5 marks for having your answer. Again, if you have 4.7 without any working, you would get all 5 marks. However, I wouldn't advise that, because if you make a mistake, you're losing possibly 3-4 marks that you could have got if you just made a silly mistake somewhere. So it's always important, especially on a calculator, to show you're working, because the examiner cannot see what you have typed into your calculator. So you need to make sure you're showing you're working out. And that is question 9. So we're now on to question 10. You have cylinder A and cylinder B. We can see that in the diagram are mathematically similar. Now, similar shapes have been on the exam every year for the past 4 years, so it's highly likely to be on there. Now, I know there was a similar shapes question on paper 1, but it often comes up more than once, having looked at the pattern over the last 4 years. So the length of cylinder A is 4 centimetres. We can see that because it's here. The length of cylinder B is 6 centimetres. Again, we can see that because it's here. The volume of cylinder A is 80 centimetres cubed. Calculate the volume of cylinder B. So, similar shapes are linked. Again, here we are using ratios. So they're linked in a ratio, or they're linked by a scale factor. So you can either do it by working out the scale factor, or you can write it as a ratio. So I have got, let's do it a different way because we've already worked with ratios. So A has a length of 4 centimetres and B has a length of 6 centimetres. So you can work out the scale factor when you have the length. So what have I multiplied 4 by to get 6? Well, the easiest way to do that is to do 6 divided by 4. You can again make sure you use your calculator. That will give you 1.5. So my scale factor here is 1.5. So I know when I'm going from A to B, when it's with a length, I multiply by 1.5. Now the key here for similar shapes is your scale factor. When you go for an area, your scale factor will be your length scale factor squared, and for a volume, your scale factor will be your length scale factor cubed. Okay, and people often don't do that, and that's where they go wrong. They just still stick with this 1.5. But when you're going from an area to area, you have to square the scale factor, and volume to volume, you have to cube the scale factor. So that's really important, that piece of information there. So I have been given the volume of A. So the volume of A is 80. And I've got to work out the volume of B. Well, if I was going from the length from A to B, I would just times by 1.5. But because it's a volume, I'm not going to times by 1.5. I'm going to times by 1.5 cubed, because it's a volume. And that is it. You would just pop that into your calculator, and that will give you your answer. So I'm just going to type that in. Your cubed button on your calculator, you'll have a button that looks like this. So you've got an x squared button, so that's for when it's squared. Some calculators have cubed, some don't. You might have just boxed where you have to put your little cubed in there. So you can just type that and it will allow you to put cubed. So you type in 80. Then you type in times by 1.5, then you might need to press this button here, and then it will have a little box where you put a 3 in there. So that will give me 270. Now notice this question does not have any units on the answer line. That's a hidden mark there. You've got a mark. If you just write 270, you're only getting 2 marks. You must write your units for the third mark, so they haven't provided them. Well, we know here the units are centimetres cubed. So you can get a mark for writing centimetres cubed, even if you can't do any of the rest of the question. So that's a really easy mark to get there. So you've got a mark for working out the scale factor, a mark for doing 80 times 1.5 cubed or getting 270, and then a hidden mark there for 3 having centimetres cubed, because there was no units on the answer line. They do that sometimes to catch you out. So that is question 10. Okay, so let's have a look at question number 11. John wants to estimate the number of fish in a pond. He catches and tags 80 fish and he returns them to the pond. The next day he catches 250 fish and 16 were tagged. Work out an estimate for the total number of fish. This is a capture-recapture. Capture-recapture, not been on there for a while and is quite a common topic to come up, which is why I'm guessing it might be on there, but again, it is just a best guess, but it's definitely something worth knowing how to do because it is worth 3 marks. So let's write this out. He caught 80 fish on the first day, and we don't know how many there were in the pond in total. We don't know the total. This is what we're being asked to work out. So he caught 80 out of, we don't know, we're working it out. So I'm writing that as a fraction. And that is equivalent to the next day he caught 250 fish and 16. So 16 were tagged, and this time we know that's out of 250. So 80 were tagged out of, we don't know the total. Then 16 were tagged out of the 250 that he caught. So we can use this equivalence here to work out an estimate. That's why it's only an estimate, because we're never going to know exactly how many fish there were in the pond, to work out what's going on here. So again, similarly to the last question, I need to work out how, if you look at 16, how do you get from 16 to 80? You can then apply the same multiplication at the bottom. So the best way to do this is to do 80 divided by 16, which will give me 5. So you multiply by 5, so therefore I'm going to multiply the bottom by 5. So here, to get my mark, I'm going to do, so you'd get a mark here for setting this up, or for doing your 80 divided by 16. One of those would give you a mark. You're then going to do 250 multiplied by 5. That's your next mark there. It's only worth 3. And then your 250 times by 5 is going to be 1,250. But make sure you're using a calculator for all of these calculations. Just don't rely on being able to do it because it's straightforward. So that's it. What it might then ask you is what assumptions have been made. That's very common. What assumptions have been made in your estimate? Well, we're talking about fish here. So we're assuming that none of the fish have died, because that could happen. We're assuming that's quite a common one you can put. So none of the fish have died. This is not asking for this in this question, it's just in case it comes up. None of the fish have died. You're also assuming none of the fish have, sometimes if it's been a long time, this one it wasn't, it was only the next day, but they could have populated, so they could have had more fish. So none of the fish have populated is what you're assuming. And the other thing that's quite common that you can write, because he's marked it would die, they're in water, you're assuming that none of the dye, I haven't written the very well there, none of the dye has washed off or has come off. So they could ask you for an assumption for an extra mark. They don't on this one, but that's quite common. So it'd be something like that they're looking for. So that is 3 marks for question 11. Okay, question 12, cumulative frequency and box plots, both very, very common topics that come up year after year. So it'll be one or the other, or possibly both together, like this question, in either paper 2 or 3. I would imagine, I'm assuming, based on the previous year's papers. A university surveyed 60, so it tells you the total, 60 mathematics graduates on their starting salary. The cumulative frequency graph shows some information, so it's already drawn the graph for you. If it doesn't, and it just gives you some frequencies, so it could ask you to draw the frequency graph. It might give you some frequencies, I don't know, of 2, 10, 6, 18, 12. To get your cumulative frequency, you have to add them up. So 2, and then you'd add on the 10. That looks like a 16, but it's meant to be a 10, so that'd be 12. Then you'd add on the 6, which is 18. Then you'd add on the 18, which is 36, and then you'd add on the 12, which is 48, and so on. And then make sure if you're plotting a cumulative frequency graph, if you have to plot it, you plot it at you'll get intervals, and you must plot those at the end points of the intervals. People sometimes use the midpoint or the lowest value. If you're asked to plot it, you must use the end points. Frequency polygon is midpoint, cumulative frequency is end point, estimated mean is midpoint. So just remember that, because they are all statistical things that come up quite often. So anyway, this one's been drawn for me. That's just if you were asked to draw it. You're now having to use the graph, so you have to use the graph, okay, and it's worth normally 2 marks. I think this one's only worth 1, but it's not taken from a previous exam paper, but it is normally worth 2, to estimate the median salary. So you've got to use the graph here. Now, we're told there's 60 graduates, so the median is halfway. And you can see on your graph that it goes up to 60. Sometimes the scale will go up higher. The scale might go up to 70, but you need to look at where the graph ends if it doesn't tell you straight away in the question like this one does. So look at the top of the graph, not where the scale ends over here. But in this question, that's the same thing. So 60 people or 60 graduates, half of 60, the median is halfway. We're looking for the 30th person, the 30th person's salary. So we go down to 30. You're going to use a ruler and a pencil. I'm not going to do that on here to save time, but we go across. So this is you showing you're using your graph, and then you hit your graph and you draw a line down, and that tells me that that is £30,000 salary. This was nice and easy, this one, but things to watch out for are scale. So sometimes you need to look at what the scale's going up in before you can work it out. This one's quite easy because it's going up in thousands, and on the y-axis it's going up in ones, but sometimes it won't be. So you always divide the amount by the number of squares, and that tells you how much each square is worth. So always check the scale, because that always catches people out. People don't check the scale. So divide the amount by the number of squares, and that will tell you how much each square is worth. Now this one leads on to a box plot question. My battery's getting low. So the 60 mathematics graduates had a minimum salary of 16. So this is related to the cumulative frequency graph. Minimum salary of 16 and maximum salary of 48. Use this information and the cumulative frequency graph to draw a box plot. Well, we've already used the graph above anyway to get the median. So when you draw a box plot, it will look like this when you've finished it. Something like this. Okay, now I'll just show you what each value is. The first line represents your minimum. The end line represents your maximum. This line represents your lower quartile. This is your median, and this is your upper quartile. Now we already have 3 pieces of that information. So I already know my minimum because it tells me here. So my minimum is 16,000. We don't know the LQ, so we're going to have to work that out. Median we've just worked out was 30,000. Just work that out from the cumulative frequency graph. We don't have the upper quartile, so I'm going to need to use the graph. And the maximum, I'm told here, is 48,000. So before we draw the box plot, let's work out the LQ and the upper quartile and lower quartile. So we know that the median was here at the 30th person or the 30th salary. So my lower quartile will be half of that. So half of 30, we want the 15th salary or the 15th person. So I'm going to go across from 15, hit my graph and go down. So that is going to be 25,000. So my lower quartile is 25,000. This was 30,000. And now my upper quartile, you just add your median and lower quartile together because it's 3/4 of the way through. So median is half, lower quartile is a quarter, or 50% and 25%. Put those together, you've got 3/4 or 75%. So I want the 45th person, which is 30 add 15, or the 45th salary. So I go across at 45. Again, these are nice and easy. Whoa, that line's very wobbly, but you'll obviously have a ruler. That's going to be £35,000. So I'm going to put these values in below. So 25,000 and 35,000. So let's go back to red. 25,000 and 35,000 are my values. So now I'm going to plot these all in. So the first thing I'll do is just each one of these, I would just draw a line. Keep the line the same length. They don't have to be different sizes. So again, check your scale. I've got 10 squares that represents 10,000. So it's nice and easy. 10,000 divided by 10, each square is worth 1,000. Always worth doing that though. Divide the number of squares by the amount. So I'm going to do 16,000. So that is going to be here, and I'm going to do it 6 squares long. Okay, and I'm going to stick with that for the others. My lower quartile is 25,000, so that's going to be here, so 6 squares long, but again, use a ruler and a pencil. My median is 30,000, so that's going to be here, 6 squares long. My upper quartile is 35,000, so that's going to be here, and then my maximum is 48,000, so that is going to go. And then notice you join the box in the middle, but you do not put a line through the box. So I'm just going to join the middle 3 lines up first, like this, and then you do these lines on the end. They're your whiskers. So you just join the box to the minimum and maximum, and there we have it. That's my box plot for 3 marks. So you'd get a mark for working out these values here, 1 mark, and then you get 2 marks for the box plot. Normally if you've plotted at least 2 correctly, you get a mark, and then you get the second mark for having them all correct. So that's my box plot. So we've done the cumulative frequency, we've looked at the box plot, and now we're on to the next part of the question. So again, this is really common to ask them to compare 2 box plots. So the university also surveyed 60 archaeology graduates. So if we just go back up to the cumulative frequency graph, this is talking about mathematics graduates. So the cumulative frequency graph, the one that we've already worked with, and this green box plot here, these are maths graduates. We're now being given information about archaeology graduates. And it says, compare the distribution of the salaries of the maths graduates with the archaeology graduates. So when it's asking you to compare distributions, you need to remember these things. You need to compare an average, which in this case we've only got the median. In a different question they might be giving you the mean, but you have to compare an average with and you also have to compare either a range or an interquartile range. You can do either with this question because we can work out. So let's work out, we've got the median here, the median, so this is, let's do, actually I'm going to drop this table out and set it out slightly differently actually. I'm going to set it out so you can see what I'm doing, because you get a mark for correctly identifying values. Now it's not letting me rub out, which is helpful. It's being a bit slow. Right, there we go. Now I just need to get my pen back. Okay, so I'm going to put maths here, and I'm going to put archaeology. Help if I could write, wouldn't it? Archaeology here. Right, and I'm going to do median, and I'm going to do range. You can do interquartile range, that's fine. So the median of the maths we know from here is 30,000. Now the archaeology I have to read from here. The median is the line in the middle of the box plot, so that is 19,000. And then the range, well, the range for maths is the range between the distance between the maximum and the minimum. Interquartile range is the distance between these two. But I'm going to do 48,000 minus 16,000, which is going to give me £32,000 is the range for maths. Now if I'm doing the archaeology graduates, the range is from the biggest to the smallest, which is 40,000 minus 10,000, which is 30,000. So I've worked those values out. They sometimes give you a mark for that, but it's only 2 this one, so I'd imagine the marks are for the actual writing. So to get 2 marks, what you need to say, you must compare. Now you don't need to mention figures because we've got them here, so I would work those out somewhere on the page. You don't need to mention figures in what you write. What you need to say here is the median salary is greater for the maths graduates, because we can see that. So you need to say it's greater, or you can say the archaeology is smaller. But we can see here the median for the maths graduates is greater for maths graduates. I'm going to write over here because obviously it's difficult for me to write small on my pad that I'm using. Okay, so the median salary is greater for maths graduates. Now you have to get the second mark, you have to write a sentence on each, a sentence like this on the median and the range. That gets you your first mark for having both of those sentences correct. And then you have to interpret one of them to get your second mark. So the easiest one to interpret is the median because it's an average. So you need to then mention that word. The median salary is greater for maths graduates, meaning they earn more, because we're talking about salary, earn more. And you have to say on average. So a sentence comparing, so saying which one's bigger or smaller, and then a sentence interpreting that that is an average. Then we also need our sentence about the range. So we say the range, sorry about my writing, hopefully you can listen to what I'm saying. Range is greater, or the range of salary is greater for maths graduates. Now you can interpret that as well, but it's not going to get you any extra marks, but you might want to do it just in case they suddenly decide to change the mark scheme. So the range tells you about variation or spread. So you need to mention that, or you can talk about consistency. That's what the range is. So any of these words you need to talk about if you're talking about the range. So you could then say, because the range is greater for maths graduates, which means their salaries are less consistent, their salaries are more spread out, their salaries are more varied. You can say any one of those sentences if you were interpreting. So less consistent, because the smaller the range, the closer the values, the more consistent they are. So you'd say they're less consistent, they're more spread out, or they're more varied, if you wanted to interpret the range as well. So that is it for question 12, and it is normally box plots and cumulative frequency. They're worth lots of marks, and make sure you know those, because 6 marks is almost half a grade on a paper, on one paper. So yeah, make sure you revise those if you're not particularly confident on that. Now we move on to question 13, and question 13 is asking you to find the perimeter of this triangle here. Now, in order to do perimeter, we need to find the distance all the way around the edge. So we are going to need the length of this side and this side here. This is a non-right angle triangle, so that tells me I am going to be using either sine or cosine rule. And this has been on paper 2 3 out of the 4 last years, 4 years, and when it wasn't on paper 2, it was on paper 3. So, and they give you the formulas for this, so it's highly likely to come up on paper 2 or 3. My guess is paper 2, but we shall see. So we need to find these two sides here. Now the trick here is cosine rule you would use whenever it's got 3 sides involved, so anything to do with 3 sides. So that means you've got 3 sides and you're finding the angle, or you're finding the third side. So at the minute I've only got 1 side, so I know I'm not going to be using that to begin with. I might use it afterwards, but let's see. We know we're going to have to start with sine rule because I've only got 1 side. And sine rule, what you want to look for is being able to make a cross in your triangle with side and angle opposite each other, side and angle. Okay, so the side and the angle have to be opposite each other. So if I look here, the side I've already got is opposite this angle here. So I've already got 1 part of the cross. So if I use this angle, I'm going to use it to find the side that I've labelled X up there. You could, if you wanted to, work this angle out, because its angles in a triangle add up to 180, and use that one. But that's just creating more work for yourself. Sometimes you do have to do that, so just be aware of that. So I am finding a missing side. So sine rule on your formula sheet is written like this. And it's got the sides on the top and angles on the bottom. And they've given you this, so you don't need to remember this. So it's always written like this, but you actually only need to use this part of it because we're looking at 2D, not 3D. You'd only use the 3 parts if you were in 3D. So we're only looking at 2 parts here. And we've got 2 angles, 2 sides. So little letters, small letters are sides. So little a will be a side. Big A will be the angle that's opposite it. Okay, same with B and little b and big B. Now, what I would say is people get confused with the formula and the letters on the triangle. Don't worry about the letters on the triangle. They are actually irrelevant unless it's indicating which angle it's finding. You don't need to worry about using the letters on the triangle and matching that to your formula. This is just saying this side here, this little a, is opposite big A. So if we said that 13.1 was little a, big A would have to be 105 because they are opposite each other. Okay, same with B. If we say little b is X, the side we're trying to find, big B would have to be 48 because they are opposite each other. So that's how the formula works. Okay, so we're going to use that now. I'm just going to get rid of my... You don't have to cross the sides out in your exam. I was just giving that to you as an example. So I am going to use this part of the formula just drawn over it. That's not helpful. I'm going to use this part of the formula here to find side x. So because I want x, I'm going to start with x first. So I'm saying that x is little a, therefore the angle opposite little x is 48. So I'm going to write sine 48 like that. Is equal to, and the only other side I have that I've got, or the only side that I've got is 13.1, and that is opposite to this angle here, so it's 105, so I'm going to put sine 105. Remember, the angle always goes with sine. If you're finding an angle and not a side, you can flip this upside down, so you can, and it's sometimes easier to do that, you can rewrite it like this, and you can use it that way round. We don't need to do that because we're finding a side, but just for reference, you can flip the formula upside down if you're finding an angle, and it still works in the same way. So, let's carry on with the question that we're doing. So I'm just getting rid of that there so it doesn't confuse you. So I've got x over sine 48 equals 13.1 over sine 105. Now I need to get x on its own. So I need to get rid of this sine 48 on the left hand side. It's currently dividing. So that's telling me I need to times by sine 48. So I have to do the same to both sides. You should obviously know how to do this already, but I'm just showing you just in case. So when you times by sine 48 and divide by sine 48, they cancel out. So that leaves you with just x, which is what we wanted. And if I times by sine 48 and divide by sine 48, on the other side, if I times by sine 48, I end up with 13.1 times by sine 48 over sine 105. You can write it like this, or you can write it like this. They're both exactly the same. You can, either way, you can put them into your calculator like this, or you can put it into your calculator as we've just written it here. So all you would do then is pop that into your calculator and work out your answer here. Okay, now once we've got our answer, again, like I said to you previously, I would not round your answer until the very end because you can lose an accuracy mark. Okay, so I'm going to quickly work out what that answer is, but I'm going to leave it unrounded until the very end so that I don't lose any accuracy marks. So I've done 13.1 times sine 48. I would just type that in using the fraction button. Unfortunately, I don't have a calculator handy, so I'm having to do it manually, but I would literally type it in exactly as it appears and use the fraction button. So we have got an answer of 10.07861. Let's round it there. So I've kept it quite long before I've rounded, but remember you can use the answer button on your calculator, and I would definitely advise doing this. Okay, so that is side x. So let's get rid of some of this up here so you can see what I'm doing now. So I'm going to get rid of this. So I've got side x. I now need to find, so I now know that this side up here is 10, I'm just going to put 10.1 on the diagram, but we know the full answer down here. So I'm going to now find the side that I called y. You can call it anything you like. So there's two ways you can do this. So it depends what you prefer using. If you're comfortable with sine rule, you may as well carry on with that. You would then need to work out this angle here, and you could work out y in the same way that we've just done here. Or because you're finding the third side, you could use cosine rule because you've now got two sides and you're finding the third side. So I am going to do it that way just to show you both cosine and sine, as we don't know what's going to come up in the paper. But either way, I am actually going to have to work out this angle up here, this angle here. Now this is where the letters on the triangle come in handy. This is called angle BAC, or you can go the other way and call it CAB. Okay, so angle, I'm going to call it BAC, is equal to 180 minus 105 plus, I'm going to have to get rid of these lines because I've drawn over the angle, plus 48. There, so that's angles in a triangle that you should know basic knowledge of that. 105, add 48, adding the two angles I've already got and subtracting that from 180. So that's going to give me 153. Subtract that from 180 and I get 27. Remember, use your calculator even for simple calculations like this, because I can't tell you the amount of times I've seen silly mistakes made because those things are not checked. So you would need to find that angle first. Now, cosine rule, I'm going to draw in a different colour for you. When you're finding a side, cosine rule is written like this. A squared equals b squared plus c squared minus 2bc cosine a. That's for when you're finding a side. It is rearranged for you for when you're finding an angle. So you can use the other one, the rearranged one that starts with cosine a if you're finding an angle. So, just to, as well, again, ignore the letters on the triangle. They are irrelevant in my formula. Okay, they are only relevant when labelling sides and angles. So, little a has to be the side that I'm trying to find. So that's got to be my y. Therefore, big A has to be the angle opposite it, which has to be your 27. And then B and C can be either way around. It doesn't make any difference whatsoever. So I'm going to substitute that in here. I'm going to put y squared, or you can leave it as a squared. B and C are going to be 10.1 and 13.1. So I'm going to put 10.1 squared, add 13.1 squared, minus 2 lots of 10.1 times by 13.1. Times by, I'm running out of space, cosine of, and the angle has to be 27 because that is the one opposite the side that I'm trying to find. You then would work all of that out on your calculator, but remember that gives you y squared. So once you've got y squared, you can use square root. So once you've got the answer to this, you can do square root of whatever your answer was using your answer button, or you can put the square root in at the start and square root the whole thing. It's completely up to you which way you do it. So you would literally just type that into your calculator again, exactly as it appears. So I'm just going to type that in now. So 10.1 squared, add 13.1 squared, minus 2 lots of 10.1, 10.1, times by 13.1, times by cos 27. So I'm not square rooting first, I'm working out the answer, and then I'm going to square root my answer. So I've got 30, I'm going to do the square root of, I've got 37.8, but it's a much longer number. That's why I would use your answer button when you're doing the square root. So I'm going to do the square root of my answer. So I'm going to square root it, and I get 6.151573 and so on. So now I have found the answer to y. So I'm going to write that up here as 6.2 rounded. It doesn't matter on the diagram. So I found my sides, and now I've got to find the last thing, which was my perimeter, and it's to 3 significant figures. So because I've been asked to round to 3 significant figures, I can round these numbers to 3 significant figures. So I'm going to round 10.07 to 10.1 because that means it's got 1, 2, 3 significant figures. I'm going to round 6.15 to 6.15 because that's 3 significant figures there, and I already had 13.1 in my diagram. So the last thing that I'm going to do is I'm going to add those together. So 13.1 from my diagram, add 10.1, add 6.15. So I add those together, and that will give me my answer to 3 significant figures. Or you can round right at the very end and use your longer answers if you would prefer. That's probably better, but this should still give you the correct answer. Add 6.15, and that gives me 29.35 as my perimeter. 29.35, and I would put meters. It would imagine it would be on the answer line, but if not, that will give you a mark. So yes, you could use sine twice, sine then cosine, and then you add your three sides together and you have got your perimeter. But yes, it's been on the paper every year for the past 4 years on one of the papers, and in paper 2 in particular on at 3 out of the last 4. So it is definitely sine and cosine where you're given the formulas. It's definitely advisable to revise if you don't know how to use those. So yes, the answer line didn't have meters, so you would need to put that in your answer. So that's question 13. So now we move on to question 14, and this is a bounds question. Very common, has been on paper 1 or 2, 3 out of the 4 last years. If there isn't a bounds question, there's likely to be an error interval question or something like that. It's a very, very common. So you have been asked, by considering bounds, work out the value of P, which is here. So you're doing E divided by T, to a suitable degree of accuracy. So it's really, and it's worth 5 marks. There's a lot of marks for this question. So the first thing you should do on any bounds question, which guarantees you a mark, is to write down the upper bound and the lower bound for each of the letters given that are rounded. So I'm going to do it for E and I'm going to do it for T. So E is 812 and it's been rounded to 3 significant figures. So it's been rounded to the nearest unit or the nearest whole number. So it's been rounded to the nearest 1. So to find the upper bound, it's just whatever it's been rounded to, it's just half of that. So half of a unit, or 1, is 0.5. So you find half and you're going to add that on for the upper bound and you're going to subtract it for the lower bound. So 812 add 0.5 is 812.5, and 812 take 0.5 is 811.5. So we've added that and we've subtracted it. So now I'm going to do T. It's 9.2 to 1. It's been rounded to 1 decimal place. So it's been rounded to the nearest 0.1 or the nearest tenth. And half of 0.1 is 0.05. So we're going to add and subtract 0.05 to 9.2. So I'm going to put 9.25 if I add it on, and if I subtract it, I get 9.15. The other way to do it, if you've got only worked with decimals, it's not mathematically correct, but I've got 9.2, add a 0 on, look at just the number after the decimal and know that you have to add 5 and take 5 away. Only works with decimals. So if you had something like, I don't know, 10.3, you could write 10.30. You know, you're going to add 5 and take 5 from 30, so it's going to be 10.35 and 10.25. So you can do it that way as well, but you'll end up with the same answer. So we have got, for our question, we have got 9.25 and 9.15. So that gets me a guaranteed mark there for finding one of the bounds correctly, which I've done. So now I've got to work out the value of P to a suitable degree of accuracy. So what that means is you have to find both the upper bound and lower bound of this calculation, E divided by T. We need both. We need the upper bound and we need the lower bound of E divided by T. So how am I going to get the biggest answer from this calculation? That's what's going to give me the upper bound. So to get the biggest answer from a division, I need the upper bound, the biggest number I can possibly have on the top, divided by the lower bound, the smallest possible number I can have on the bottom. That's what's going to give me the biggest possible answer with division. So the upper bound for E is 812.5 and the lower bound for T, which is on the bottom, is 9.15. So that's what I'm going to do there to get the upper bound, the maximum possible answer for that calculation. That's what that means. So then for the lower bound, which I'm going to do here, to get the smallest possible answer, it's the other way round. I need the smallest possible number, the lower bound for E on the top, and I need the maximum possible number I can get, so the upper bound for t on the bottom. So the smallest possible number divided by the biggest possible number is going to give me the smallest answer. So I need the lower bound for e, which is 811.5, divided by the upper bound for t, which is 9.25. So this here gives you, I'd say, another 2 marks, one for each of those correct. So you get a mark for finding the bounds, a mark for the upper bound correct, and a mark for the lower bound correct. And then obviously you would need to work out what those are. You may get a 4th mark if you've then got them both correct, is normally how that works. So the upper bound, if I work that out, now what you want to do here is don't write out quite a lot of numbers after the decimal. So the upper bound is 88 point, and then I'm going to write 7978142. You don't need to write the whole number, but I would write definitely quite a few number of decimal places. So I'm now going to do the same with the lower bound and work out what that gives me. So I've got to do 811.5 divided by 9.25, and that gives me the lower bound here, which is equal to 87.729729, etc. Okay. So now, because it said round to a suitable degree of accuracy, I want to round it to as far along as I can where both give me the same answer. So I'd always start here. Let's start with the tens column. If I rounded those to the nearest 10, what would they round to? They would both round, so to the nearest 10, they would round to 90. Both numbers would both round to 90. So we could use that. However, can we do any better? So let's go along to the next number and see what they would round to if we round to the nearest 1 or the nearest whole number. So if we round them to the nearest 1, this rounds to 89. That was this one. This rounds to 89, and this one would round to 88. So they actually round to different numbers, so you can't go any further. The actual best answer you can give to this one, to the suitable degree of accuracy, is going to be to the nearest 10, which is 90. However, sometimes you can keep going. So if they both rounded to the same thing here, I would then go to the 1 decimal place. If they both rounded to the same 1 decimal place, I'd go to 2 decimal places, and you keep going for as far as you can. When it starts giving you a different answer, that's where you know you need to stop. But this one, I can't go any further than 90, because when I go to 2 significant figures or to the nearest whole number, they both round to something different. So that is not a suitable degree of accuracy. So that would give me my 5th mark. As I said, your 4th mark would be having both of these calculations correct. So that is it for question 14. So question 15. It is about perpendicular lines. Now, parallel and perpendicular lines have been on paper 1 or 2 for the past 3 out of 4 years. So again, quite common. Line A passes through points 3, 1, -3, -1, and -1, 9. -3, -1, I'm just going to write them a bit bigger, and -1, 9. So they are on line A. Then line B has got -2, 1, -2, 1, and K, 4. And they are on line B, and it tells you these 2 lines are perpendicular. Now that means if line A, for example, was this way, line B would be perpendicular to it, so they meet at a right angle, and line B would be that way. So that's what they mean if they're perpendicular. And then what you need to know is if you've got 2 perpendicular lines, their gradients, so I'm going to call that M1 and M2 because you've got 2 gradients for 2 lines, multiply together to give you -1. So if you've got 2 perpendicular lines, the gradients multiply together to give you -1. So one gradient would be the negative reciprocal of the other gradient. However, this is what we're going to need, this formula here, for this question. So I am going to first of all work out the gradients as I would do if I knew all the values. So let's do the gradient of A. Let's call that M1. So the gradient of A, the gradient formula they don't give you, unfortunately, is y2 minus y1 over x2 minus x1. That's how you find the gradient. Now, all that means is, you might have heard this before, change in y over change in x, rise over run. It's the same thing, just written in a form. It's just the difference between your y coordinates divided by the difference between your x coordinates. So the easiest way to do that from here is I'm going to start with y. Now, you can either do -1 take 9 or 9 take -1. I'm going to start with -1. And I'm going to subtract 9. Now, the direction is important here. Because I've gone that way, I have to go the same way with x when I do my x coordinates here. So I'm going to do -1 take away. Hang on, that equal sign doesn't look like an equal sign. I'm going to do -1 take 9. That's my difference between my y coordinates. So now I have to go the same way for my x coordinates. So I have to start on the left. -3 take away -1. You can go either way, but it has to be the same way for both. -3 take away -1. Okay, don't forget you're taking away and you've got a -1 there. Again, here, you can try and work it out in your head, but you could make a mistake. I would do it all on a calculator and it will tell you the correct answer. Just make sure you have all the right signs in there. So -1 take away 9 is -10. And -3, when you subtract a negative, you're actually increasing. So -3, subtract -1, you're going to go up 1, it's -2. But you don't need to know that because you've got a calculator and it will tell you the answer for you. The answer, -10 divided by -2 is +5. So that is my gradient. My first gradient for line A, M1, is 5. So now what would I do if I knew what K was? Let's do that. So gradient of the second line. So I'm going to do the same thing. Okay, so let's go. I'm actually going to start on the right this side because I've got larger numbers over here. So I'm going to do, and you can do it any way around, it doesn't matter. I'm going to do 4 take away 1. So that's the difference between my y coordinates is 4 take away 1. And then if I do my x coordinates in green, I'm going to go the same way. So starting on the right, going to the left, it's K, take away -2. Don't forget you're taking away negative. K, take away -2. So 4 take 1 is 3. And when you're subtracting a negative, you are actually increasing. So that is going to be K add 2. So that is my expression for the gradient of line B. So now I'm going to have to use this formula, M1 times M2 equals -1. My two gradients multiply together to give me -1. So that's going to enable me to work this out. You'd have more space than this, but I'm going to go down here because I'm running out of room. So M1 is 5, multiplied by M2, which is 3 over K plus 2, I know is equal to -1. That's me multiplying my gradients together and getting -1. I'm just substituting it into the formula. So this is the same as having 5 over 1. If I multiply fractions, I just times across the top and times across the bottom. 5 times 3 is 15. 1 times K plus 2 is just K plus 2 equals -1. So I've now got to solve this. So to get rid of K plus 2, it's currently dividing. So I need to times by K plus 2. So times by K plus 2 times by K plus 2. So K plus 2 times and divide cancel each other out. So that leaves me with just 15 on this side. And -1 times K plus 2, you've got to be careful, make sure you times it by the whole thing. So -1 times K equals -K. And then I've got -1 times 2 gives me -2. A really easy mistake to make there. People forget to multiply both terms by -2, -1, and then they'll end up with the wrong answer. So now I've got my k is negative. I don't want that, so I'm going to add k, because then I'll get k as positive on the right hand side. So when I do 15 add k, I can't do that, so I get k add 15, or 15 add k, and this has cancelled each other out, so I'm just left with -2. That's made my k positive. I'm now going to subtract 15 from both sides, and I end up with k equals -2, take 15. Again, silly, it sounds silly. Check this on your calculator. The amount of times I've seen people get this wrong when they've got right up into this stage and they make a silly mistake. -2 take 15 is -17. Okay, so the answer here is -17, and that is the final answer for 4 marks there. So be really careful, and please use your calculator even if you're super confident, because as I said before, stress in exams can make us all do strange things. So that is the end of question 15. So now we move on to question 16. And this is a graph that shows some information about the velocity of a parachutist t seconds after leaving plane. So the time in seconds is on the x-axis, and that's t in this instance, and the velocity is on the y-axis, so that would be v. Now you've been asked to work out an estimate for the acceleration of the particle. I've drawn over the words again there, so let me just rub that out. So an estimate for the acceleration. So this type of question has come up 3 out of the last 4 years on either paper 1 or 2, and wasn't on paper 1. So again, could be on there, could be on paper 3, might not be there at all. But let's go through how to do this. And it's worth lots of marks. It's really worth knowing, especially where it's quite a common topic. If you are asked to do the acceleration on a graph, the acceleration is the gradient of the curve at that point. Now, to do the gradient of the curve, I don't know why I put a dot there. To do the gradient of a curve, you must draw a tangent, because if you don't draw the tangent, they don't give you the marks. So without that, you don't get the marks. So you must draw a tangent to the curve. So we're estimating the acceleration of the parachutist at what time, where the time is 6 seconds, where t equals 6. So what you need to do is t equals 6. If we go up from 6, t equals 6 on my graph is here, where that little blue dot is. So I need to draw a line that is in line with my curves. This is going to be quite tricky because I'm doing it without a ruler, but so you need to try and get it in line with the direction of the curve at point t equals 6. So that one's out, that's no good. So I want it to be like that. That's probably still a bit out actually, so I'm going to redraw that. This is why it's really important to use a pencil and a ruler. Obviously you would make sure that your line is straight. So that is in line with the curve where t equals 6. You probably want it a bit straighter than that, but we'll go with that for now. So you now want to find the gradients. You get a mark for having a tangent drawn. That gives you a mark. That's one of the 2 marks. Now to find the gradient, you need to draw yourself a triangle, or you need to just use 2 coordinates. Now you want to choose exact points. Now where I've drawn my line, it's going to be very difficult to see, so I'm actually going to get rid of the line for the minute, because I sort of roughly know where I'm going from, but you need to have that tangent drawn in there. So I'm going to use this point here, and I'm going to use this point here, and I'm going to draw a little triangle there so you can see what I'm doing. But obviously that would be in line with your tangent, not just drawn straight from the curve. So I'm going to write down the coordinates of those points so that I can see what I'm doing. So the first point that I have marked here has coordinates 5, 42. They give you a little bit of leeway here because everybody's tangent will be slightly different. So 5, 42 is my first point, and the second point that I have used is going to be I'm just trying to see what I've done there. So that's going to, now this is where you need to be careful because that's 7. So each square is not worth 0.1, each square is worth 0.2. So where I have drawn mine is going to be at 6.6. So 6.6, be careful you read the scale. Luckily the y-axis, the velocity goes up in ones. So 6.6, and then I have got 48. You need to make sure you're really careful and look at the scale. It's comes up a few times. You have to check the scale whenever you're using anything with a graph. So these are my 2 points, 542 and 6.648. And in order to find the gradient, I can use what I've used with my previous question. It's just the difference between your y coordinates, these are my y coordinates, divided by the difference between your x coordinates. So I'm going to do, and again, whichever direction you go, make sure you go the same direction. The bigger numbers are on the bottom, so I'm going to subtract upwards for both. So for y, I'm going to do 48 minus 42, because they're my y coordinates. They come second, and then for x, I'll do that in green. I'm going to do 6.6 minus 5. That's just change in y over change in x, and that will give me my gradient, which gives me my acceleration. So again, you would just pop this into your calculator and work that out straight away. I've got 6 divided by 1.6, and then I'm going to work that out on my calculator. And as I said, they give you a little bit of margin of error here because everybody's tangent is slightly different, so they'll give you a range for your answer. So my answer that I've got is 3.75, so I'd imagine they'd give you a range of anywhere between, I don't know, 3.5 and 3.9 or something like that. So as long as your answer falls within that range and you have a tangent correctly drawn, they will give you the mark there. So that's that for the acceleration. So I'm going to zoom in a little bit on this part here because you've been asked to work out now an estimate for the distance fallen by the parachute in the first 12 seconds using 3 strips of equal width. So distance under a curve, you want to find the area. Okay, that will tell you the distance for this type of question. And when it tells you to work out strips, you're putting them into triangles and trapeziums. It might be a triangle and 2 trapeziums, but we'll look at that in a minute. So you need the trapezium formula, which my students in my class like me or don't like me singing to them. Half the sum of the parallel sides and times the distance between them. That is how you calculate the area of a trapezium. I know they're probably cringing right now. But anyway, you don't need my song because you have the formula. But it's half the sum of the parallel sides and times the distance between them. So you're going to need this because you're going to split your graph into trapeziums. So we'll look at how we use that now. So I'm going to zoom in on my question. I'm going to complete this at the top. So I've got to use 3 strips of equal width for the first 12 seconds. Well, the first 12 seconds actually on my graph here is the whole graph. So let's just zoom in. And what I'm going to do is I'm going to get rid of this working out here so that you can actually see, we can see properly what we're doing. So let's just rub this out here so that I can see exactly what I'm doing. So that was my working out for the last question. Let's rub this out. I'm going to get rid of this. So I've got some space to do some working out on the side. Obviously you'll have lots of room. They give you plenty of room to do your working out on the page. Obviously I haven't got that because I've screenshotted the paper onto this document in order to be able to go through it with you. So we've got to split it into 3 equal strips. So if it's 12, the first thing I want to do is find the width of the strip. So 12 divided by 3 means I am going to split it into strips of 4. So that's the first thing that I'm going to do is split it into strips of 4. So I'm going to go 4 here, and then I'm going to go up here. So I need to find the area of 1, 2, and 3. So 1 you're going to just assume that that is a triangle. The reason it's an estimate is because obviously it wouldn't exactly be a triangle because it's a curve. So you're going to do it as an estimate. I'm just going to rub that line out again because you're not going to need to be able to see the point. The point that I'm using is that point there. And that's where my line goes up to. So I won't quite reach that. Now I still can't see, so I can see the point now. Okay, so let's go with number 1. It's a triangle, should be nice and easy. So the base has, we should know they're all 4. Anyway, the base of each one. So base is 4. Height of my triangle, so I look up here, that went up to here, which is 35. Yep, 35, so 4 times 35. Don't forget, with a triangle, you have to half it to find the area. So that's the calculation that I'm going to be doing here. So that's going to give me 70. So that's number 1. Right, number 2, this is where my trapezium formula comes in. So half the sum of the parallel sides and times the distance between them. So I'm going to put a number here, here, and here. Now the distance between them, because your trapezium is on its side, this is what the trapezium that you've got looks like. And it's like that. Whereas, so the distance between your 2 parallel sides is here, and A and B are these 2 sides here. So your distance, we know, is going to be 4 because that's the width of each strip. This is the distance between my 2 parallel sides here. So that's going to be 4. A and B, well, we already know A because it's the same point that I used here, which was 35. So you're using the previous point. Now we just need to look at what this point here is. So we know that that's it goes up to 8 there, so that's 51. 51. You need to be exact here, especially if they're decimals. They're really strict on it being exactly correct or you don't get the marks. So I'm going to do half of 35 add 51, which is 86, but you can just pop that straight in a calculator and then you're going to times your answer by 4. So if I pop that into my calculator, that is going to be 172. Let me just double check that, but because I've done that in my head, this is what you shouldn't be doing. You should make sure you're working them all out on a calculator. 86 times by 4 is 172. Yes, correct. Right, then I'm going to do number 3. And again, you've got another trapezium, so half the sum of the parallel sides. We know the distance between them again is going to be 4 because that's the distance between my 2 sides. That's the other side here. So you're going to need that point there. Now we already know this point here, we just worked with that one. That was 51. We had that in the previous trapezium. And the last point that I've got here is 54. But make sure you are accurate. So I'm going to be doing half of 105 times by 4. So that is going to be 210. But I'll just double check that again on my calculator, as you should be doing. Don't do it all in your head. Make sure you've got a calculator for that exam. Otherwise you could end up losing lots of marks. So that's it at 210. So now that I've got my 3 areas, all I do with these is I add these together and that gives me my final answer. So it's 70, add 172, add 210. So I'm going to do that then. 70, add 172, add 210. And again, use your calculator to add these together. 210, add, I'm going to do that, 172, add 70. And that gives me 452 and that's distance. So if we look at the distance travelled, we need units here because there aren't any units. My velocity is in meters per second. It tells me that here, m/s, that means meters per second. So therefore my distance would be in meters. You may not lose a mark if you don't put the units there, but always do it just in case so you can get that from the diagram. So yeah, that is it for question 16. Question 17, I don't know why, I'm just convinced there's going to be a hard indices question like this. They like this sort of question, and it's been on 3 out of the last for paper 1s or 2s, something complex like this. Now, it's actually a lot harder than it looks. So I'm going to draw it a little bit bigger because it's quite hard to see there. 9 to the negative a half equals 27 to the power of 1/4 divided by 3 to the power of x plus 1. And it says find the value of x. Really common question. Now what you need to do, what you should notice here, you see this 3. If you look at 27, 27 can be written as 3 to the power of something, and 9 can also be written as 3 to the power of something. So once you've got, you want to get them so that the bases are all the same. So I'm going to rewrite them. So 9 is the same as 3 squared. And I'm going to put it in a bracket because don't forget you still had the power of negative a half. That doesn't go anywhere. I've just replaced this 9 with 3 squared. That's it. Okay, so I want to write them all with the same base because then I can use what I know about laws of indices. So 27 can be written as 3 cubed. 3 times 3 is 9, times by 3 is 27. Again, put it in a bracket because you still had this power of 1/4 here. That doesn't disappear. Okay, and then divided by, well, this one's already 3, so that's x to the power of x plus 1. So that get you a mark for writing one of them or both of them correctly with a base of 3. Could be 2, could be 5, it could be any number, but you should recognise that when you see it, that they can all be rewritten. Now what I need to do is simplify. This will be where my next mark comes from. So I need to get rid of the brackets. So when you've got brackets and you've got indices, the rule is you multiply the indices. So 2 times negative a half. Well, half of 2 is 1, but it's negative, so it'll be negative 1. And then I've got 3 times 1/4, which is 3/4. So 3 to the power of 3/4 divided by 3 to the power of x add 1. So actually, this question's only worth 3 marks. It might be that you don't get a mark up until this point. Questions like these are sometimes worth more than 3 because there's quite a few steps involved. So now what I need to do is apply my knowledge of indices. When I'm dividing and the bases are the same, all I need to do is subtract my powers. So what this is telling me is that this is equal to this minus this. If it was times, you'd add them, because both sides are equal. So when I write this as a single base of 3, we know that the answer is negative 1. So basically, once I subtract these two powers, I'm going to get an answer of negative 1. So once I've got the bases the same, I take the bases away and I write an equation. So I'm going to write negative 1 equals 3/4 minus x plus 1. So this would probably be where your second mark would come in for using your laws of indices knowledge. You've got a mark here, somewhere in here, and then you've got a mark for writing the equation. So now I need to solve it. So first thing I notice here is that x is negative. I don't want that. So I am going to add x first of all. So that gives me x take 1 equals 3/4 plus 1, because by adding x on the right hand side it gets rid of it. So now I've got to do, I'm going to get rid of that negative 1 there. So to get rid of a negative 1 you add 1. So I now get x equals 3/4 and 1 plus 1 is 2. So, and then 3/4 add 2 is just 2 3/4. Or you can write it as a top-heavy fraction, is fine as well. That would get you 4 marks for writing x is 2 3/4. Or you can write it as a top-heavy fraction. 4 times 2 is 8, add 3 is 11, so you could write it as 11/4. Or you could write it as a decimal. You've got a calculator, so you could work that out on your calculator anyway. And that is worth 3 marks. So I do think there's going to be something like that. I don't know why I do, but I just do feel like that's going to come up on one of the next 2 papers. Okay, so question 18. It's got 8 sweets in a bag. The sweets, 3 sweets are red, so 3 red. 3 sweets are blue, and 2 sweets are green. 3 sweets are selected at random without replacement. So this is conditional probability because it asks you to calculate the probability the sweets are not in bold letters the same colour. This has been on the paper every year for the past 4 years, and it wasn't on paper 1. Quite often they do put it with algebra or ratio as well, but obviously if you're confident with that you'll be fine. Just follow the process as you would do normally and then think about it as you go along and try and answer as much as you can. So I like to draw a tree diagram for questions like this. I'm going to draw it to the right here because I've not got as much room as you'll have. So I'm going to just take three sweets are taken at random. So I've got first, I've got second, and I've got third sweet. So the first time I can get a red, or I can get, hang on a minute. I need to redraw that because there's 3 sweets and I've only got branches for 2 sweets. So because there's 3 sweets, you have to have 3 branches. So I'm going to have red, blue, green. Red, blue and green. Then I can have red, blue, green the second time. Red, blue, green here. Red, blue, green here. This is going to get messy. Do you know what? I'm not going to draw a tree diagram. I would do if you're not going to have so many branches. You can if you want to. I do like to draw a tree diagram for this sort of question because it's visible. But I'm going to end up with lots of branches. So let's try and look at a quicker way of doing this question without having the tree. So I am going to calculate the probability the sweets are not all the same colour. So that's going to be a lot of calculation because I could have red, then blue, then green, red, then green, then blue, etc., etc. So what is sometimes easier with questions like this is to do the opposite of this. So the opposite of them all not being the same is them being the same. So I'm going to work out the probability they are the same colour because then I've only got 3 options. I've got red, 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 blue, 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 green, green, green. Because to do all the other options, there'd be loads. I'd have to do loads of calculating. Remember, probability has to add up to 1. So if you do the probability that they're all the same, if you subtract that from 1, you're then left with the probability that they're not the same because they're the opposite of each other. So red, red, red. So there are 8 sweets in a bag. To start off with, 3 are red out of 8 in total. Now, when you go along the branches of a tree, or you want this probability and the next probability, you multiply. So I want and the next one to be red. However, because a red's already been removed from the bag, there's now only 2 and the total has gone down to 7. So the probability the next one I pick is red is 2 out of 7. And then it goes down to 1 out of 6 because it says without replacement. So then I'm going to do blue, blue, blue. So blue, I've got 3 blue out of 8, but if I've taken a blue the first time, that now goes down to 2 out of 7, and then it goes down to 1 out of 6, just like with my red. And then green, 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 I had 2 sweets that were green, so 2 out of 8. Now, if I've taken a green the first time, I've only got 1 green left out of 7. I can't pick a green the third time because they'd all be gone, so the probability of that is 0. Out of 6. So I can't actually get 3 greens. It's not possible. So probability of them all being the same is me working out each of these, and because I've got more than one option, you then add them together because I have this or this or this. So and is multiply, and you multiply or you add. People often get that the wrong way round. Okay, just remember that. So again, you're going to work this out on your calculator. The only difficulty with this is, well, it doesn't matter because you can use your calculator anyway, but it does simplify the denominator of the fraction. But you're going to get 336 on the bottom. You might get simplified answers for this because your calculator will automatically simplify the fraction for you. We know that's going to be 0 at the bottom there. 3 times 2 is 6, times by 1 is 6. And then 3 times 2 times, yeah, that's going to be 6 as well. So again, as I said, you may get simplified answers. So probability they are the same is going to be 6 out of 3, 3, 6. Add 6 out of 3, 3, 6. Add 0 out of 3, 3, 6. And that is going to be 12 out of 3, 3, 6. So that's probability they are the same colour. So probability that they are not the same colour, is going to be 1 minus the probability that they are the same, because probability adds up to 1. So that is going to leave me with 336. Take away 12 is 324 out of 336. And again, your calculator probably simplifies that for you. A simplified answer is fine. So is this answer. Okay, simplified or unsimplified, that is the correct answer, and that will get you all of your marks. So that was much easier than having to draw a tree. So if you've got lots of things like that, sometimes you just have to sort of work it out in your head, and that is worth 4 marks. And that's the end of question 18. We are on to question 19, nearly there, 2 more questions to go. So this diagram shows part of a curve with the equation y equals f of x. So rather than it being y equals negative x squared, it just says it's y equals f of x. It just means it's a function, a graph. The coordinates of the maximum point of this curve are 2, 3. Well, we can see that because that's on the diagram. And you've got to do the coordinates of the maximum point once the graph has been transformed. So that is transformation of graphs here. That has been on the paper for the last 3 out of 4 years on either paper 1 or 2. So you've got to look at this when it's y equals f of x minus 2 and y equals 2f of x. So you will get something like this. It might not always give you the graph drawn. It might just give you y equals f of x, and it'll ask you various things about it. And it could be a trig graph, sine or cosine graph. So there's a few things that you need to know. So I'm going to write a couple of things down, and then I'll explain to you what that means afterwards. There is also in my first paper that I did an explanation of this, my first predicted paper, but it didn't come up in paper 1. If you need some more practice, you can take a look at that. So if you have something that happens outside of the bracket, so outside the bracket, then that is to do with y, your y coordinate, and you do the same thing it asks you to do. We'll look at that in a minute. And then if you are asked to do something inside the bracket, then that is to do with your x coordinate, and you do the opposite. So let's have a look at that then. So for example, if I had y equals f of x plus 2, that's outside the bracket, so that is to do with y. So all I would do is add 2 to my y coordinate. So if I had a coordinate, say, of 3, 7, if I add 2 to my y coordinate, my new coordinate would become 3, 9. So that's it. If you had something like this, y equals 3fx, it's outside the bracket, so it's still to do with y, but you're not adding this time, you are multiplying by 3. You'd multiply your y coordinate by 3. So if I had the coordinate 3, 7, for example, and I multiplied it by 3, I would end up with 321. The x coordinate stays the same. Let's do the same now with it, with it being inside the bracket. So say I had y equal f of x plus 2 inside the bracket. Let's stick with 3, 7. Now, because it's add 2, but it's inside the bracket, and x, we do the opposite, you'd actually take 2 away from your x coordinate this time. Last time we were looking at y, now we're looking at x. So you take 2 away from 3, you get 1, your y coordinate would stay the same. And then if I had 3, sorry, no, not like that, let's get rid of that. Because I want it to be inside the bracket this time. So if I now had f3x, the 3 is now inside the bracket, So that applies to x, but instead of timesing by 3, I'm doing the opposite. So I divide x by 3. So again, I'll stick with the same coordinate, 3, 7. If I divide my x coordinate by 3, that gives me 1, 7. So in the first example, my x coordinate stayed the same. The second, my y stayed the same. Sometimes you might get something like this. Could be both. You could have 3fx plus 2. So that would be telling me to do two things. So I'm doing two transformations to my graph. So if I had the same coordinate, it means outside the bracket is y, and it's the same, so I'd times my y coordinate by 3. Inside the bracket is x, and it's the opposite, so I'd subtract 2 from my x coordinate, and I would get 121. So that's how it works. All right, that's it in a nutshell. So let's have a look at the question that we've been given here, and I'll do that in blue so that you can see what I'm doing. So I don't know why I'm doing dots. So right, so I have been asked to do this here. So it is inside the bracket. Inside the bracket. So it's to do with x, and I'm doing the opposite. So if I look at my coordinate, which was 2, 3, my maximum, I'm looking at x because it's inside the bracket, and instead of taking away 2 is what it said here, I'm going to do the opposite, and I'm going to add 2 just to my x coordinate. So my y coordinate will stay as 3. 2 add 2 is 4. So that is the first one done. Now this next one is outside the bracket. So it's outside, so it's y, and I do the same that it's telling me to do. So this is a 2 on the outside, so that is telling me to times my y coordinate by 2. So let's write it out again here. Now I'm looking at y. My x coordinate will stay the same, so that will stay as 2. And it's telling me to times my y coordinate by 2. So that's going to give me 6. And then my x coordinate stays as 2 in that example there. And that is it. 1 mark for each correct. Both coordinates must be correct to get the marks. Obviously, they can be more complicated than that. As I've said, they could have multiple steps to it, but that is transformational graphs in a nutshell. Okay, so we are now on to our last question. Let's just get rid of this here so you can, I've got plenty of space. Composite functions has been on the exam on either paper 1 or 2 every year. So it's something that's very common. They might choose not to put it on there this year. We don't, who knows? They do that sometimes. They'll have a break. But it is something that is generally worth quite a lot of marks if it's on there. So we'll have a look at this. So the functions fx and gx are given by the following. So it's given you the functions. It's given you the equations here. So 3x minus 1 and 3x minus 1 and 2x plus 4. So the first thing I've got to do is calculate the value of, let's do it over here, fg2. So all that means, when you've got composite functions, it means you're combining functions. And because g is on the inside, you're going to put g into f, essentially. So first of all, let's work out what G2 is. Okay, and once I've got the answer to G2, I can put that into F. So G2 means all I'm going to do is I'm going to substitute 2 in for my x coordinate here. Because instead of Gx, it's now G2, so it's just saying replace x with 2. So 2 lots of 2 instead of 2 lots of x plus 4 gives me 4, add 4, which is 8. So that's G2, but I've now got to put this into F. So f of x, I've got to put it in, so I'm going to put 8 into f of x, and that's this one here, which is 3x minus 1. So instead of 3x, I'm going to write 3 lots of 8 minus 1. 3 8s are 24. Minus 1 is 23. But again, even simple calculations, please check them on your calculator, even though they might seem really, really easy. Okay, so that's the first one. Next one, similar, but this one says FF3. So you are F3 is on the inside, so you're going to do that first. F3. So I'm going to put 3 into F. F is 3x minus 1. So I'm going to do 3 lots of 3 minus 1, which is 9 minus 1, which is 8. And then because I've got to put that back into F, okay, F has got to go back into F, so I'm now going to do F8. So F is 3x minus 1, so I'm going to do 3 lots of 8 minus 1, which is 24, minus 1 is 23. So I've actually got the same answer here as I got for the one above. Now, this one here, there is no number, it's algebra, because it says GFX. So again, same principle applies here. So you are putting f of x, so that into g. So what that means is you are putting the whole of f of x into g. So rather than substituting a number in, you are substituting in the whole expression. So I am going to, no, it's not letting me get my pen up. Yep, so I'm going to substitute. Remember, the one on the inside, f of x, goes into the one on the outside. So all of this, rather than me substituting a number, is going to go into g of x, where x is. You're going to replace this x here with everything that you've got there. So all that looks like is, if I write g of x out, g of x is 2x plus 4. So I'm going to replace this x with f of x, which is 3x minus 1. So I've replaced that. Everything else stays the same. So that is what I would write here, and you're just going to then simplify that out. So you're going to expand the bracket, so that gives you 6x minus 2. That's 2 lots of 3x, 2 lots of negative 1. Add 4. 6x minus 2, negative 2, add 4 is positive 2. So that is your final answer for 2 marks. And that is the basic idea of composite functions. It's just substituting one thing into another. They can get quite complicated with algebra. You can sometimes end up with quadratics that you have to equal to 0 and factorise to solve. They might equal them to each other, but that is just sort of a basic example of how composite functions work. And that is the end of the paper, because that is question 20. So as I said, it's a best guess. I can't promise you these topics are going to come up, but from having looked at the papers over the last 4 years, they are things that are quite common. There might be some new things that haven't been on there for a while, but these are definitely things that would be worth revising for paper 2 and 3. Obviously, once paper 2 has happened on Wednesday, I'll do another predicted paper for paper 3 next week. But best of luck with your exam on Wednesday, and please, if you have any questions between now and then, please feel free to add in the comments, and I will get back to you if there is anything you're not quite sure on. So yeah, good luck for Wednesday. I'm sure you will be fantastic.